never hold back spring. You can be sure I will never stop believing. The blushing rose that will climb, spring ahead or fall behind. Winter dreams the same dream every time. Baby, you can never hold back spring. And even though you've lost your way, the world is dreaming of spring. So close your eyes, open your heart to the one who's dreaming of you. And you can never hold back spring. Remember everything that spring can bring. Baby, you can never hold back spring. Baby, you can never hold back spring.
All right, well, we'll continue where we left off here in a moment. But before we do, I wanted to bring your attention to the fact that assignment 1, your first actual assignment, is due this Friday by midnight, 1 second before midnight, according to the system clock. And I have been periodically updating this assignment 1 thread on where you should be. So, for example, by the end of the day, you should have the first 2 exercises completely done and handed in. And you should have a good start on that 3rd exercise, where at least you're loading stuff up from the file and maybe doing those first 2 simple reports where you're just counting up the number of doses of each drug or whatever it is. And that will give you plenty of time to debug and fix things all the way till Friday. Some updates here as well. I haven't been seeing this in this section, but in case that you do fall into one of these, you should be creating a brand new project, just like we demonstrated on day 1. You should not be using a module info file at all. Unless you know what you're doing with the module system, it is not something that you want in your project. The starter files are not in a GitHub repo. You should be downloading those and dragging and dropping them into your Eclipse project. And finally, make sure that you're following the instructions for bringing in JUnit into your project. Those are in the handout. So, to continue where we left off last time, we were looking at basic searching and sorting. Java provides built-in searching and sorting algorithms like any programming language does, any decent programming language would. And you need to use custom orderings in order to use you need to use comparators, excuse me, to do custom orderings and sorting with different user-defined types. So let's just go back to the example that we were running through last Thursday. And I've got a list of numbers here and a list of names, and they're not in any particular order. And if you just use the regular old sorting algorithms, .sort and .sort, right, for the names. It understands these things because integers are built into the language. Strings are built into the language. And consequently, when it prints them out, let's go ahead and just look at the first two here, right? Initially, it's unsorted. And the natural ordering that it puts them in is in non-decreasing order, in other words, ascending order. So 1, 2, 3, 4, dot, dot, dot to 9. Likewise, the same thing with strings, except that it's lexicographic. So if I have lowercase a Aaron here, they're last because it's according to the ASCII text table, right? If you want a different ordering, for example, descending ordering instead, or with respect to ignoring the case, right? Then you need to roll your own comparator. And that's where this comparator comes in. We have a comparator, and what is this comparing? It's comparing integers. And it defines this function called compare that returns something negative, positive, or 0 depending on the relative ordering of these things. If A comes before B, then it should return something negative. If B comes before A, or A comes after B, then it should return something positive. Otherwise, if they're the same, then it should return 0. Right? And we use this new anonymous inline declaration here in order to create this comparator. So compare A and B, and it returns something positive if A comes before B. Why? Because, well, if A were 10 and B were 5, if it's descending order, as I've labeled it here, then this means that they're in order, right? And therefore, A is greater than B, should return something negative. And if they're out of order, say 5 is less than 10, right? Then we need to return something positive because the sorting algorithm needs to swap those two things to put them into order. Right? We also looked at the same thing for strings, right? You can create a comparator for strings. The difference is that the Langle-Wrangle there is now parameterized that this is for strings. The compare method now takes strings A and B instead of integers A and B. And here I'm just reusing the built-in sorting or built-in comparison function here, compare to ignores case, which follows the same exact pattern, something negative, positive, or 0 depending on the relative ordering. But I've negated it here because what I want is a descending order. Right? And when I do that, I get Zoe, Joe, dot, 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 and now Aaron and Aaron are together just because it's ignoring the case. Right? All right, so what else? Oh, and then we looked at binary search. Remember that binary search works by checking the middle element. And as long as it's sorted in a particular order, then it knows, well, if I'm searching for 7, I know that it's in this half of the list. If I am searching for 7, I know that it's not in this half of the list. So it goes and cuts the list in half each and every single time. If you have an array or a list of size, say 1 trillion, instead of having to do 1 trillion comparisons, 1 trillion operations, you only have to do about 40, right? Because it's exponentially faster. If you are trying to do something like a naive linear search, where you're going throughout this entire thing, finding the 9 by starting at the beginning, that's not it, that's not it, that's not it, you will not be able to be successful in that last report on assignment 3. You need to use smart searching and sorting algorithms to do this. Right? Binary search, all you need to do is search what the list that you're searching for, the key that you're trying to find, and then make sure that you're using the exact same comparator. Right? What if you're not using the same comparator? So remember, I'm searching for 9 here. We're going to sort it, print it out, and then we're going to report whether or not we found it. Right, there we go. There. 1, 2, 3, 4, 5, 5, 6, 7, 9. Certainly, 9 exists in there. It's right there. But did it find it? Remember that a negative value means that it did not find it. Why didn't it find it? Because it was expecting it to be in descending order. But was it in descending order? Nope. So what ends up happening is it looks in the middle index and it says, well, this must be sorted in descending order. So if 10 exists, where is it going to be? Over on this half of the list. That's why it doesn't find it. If you are going to use binary search, it needs to be sorted in the exact same ordering as you're searching for. This and this need to be the same. Okay? All of that is now in your notes. What I want to do now is I want to find some reports here. Right? What I want to do is I want to find the worst book. I want to find the best book. I want to find the oldest book. I want to find, I don't know, all books by Terry Pratchett. There we go. Right? So those are some reports that I want to produce based on the book data that we'd previously seen. Let me go ahead and bring up, oh, no, I didn't cut and paste it, sorry. Let me go ahead and, at some point we did it because I've got it in the notes there. But in any way, there we go. I'll cut and paste this over here. There we go. All right, so I've got a bunch of book data here, right? And the book data consists of a title, an author, maybe which is a first name and a last name, a publish year, an ISBN, and a rating, a Goodreads rating, Goodreads.com rating. So I've got all that data right here, and I've also got this other column here called ID, and that is actually the ID. If you go to the Goodreads.com, that's how they identify that particular book. So for example, I'm actually reading this right now, The High Crusade by Paul Anderson. There is the ISBN 13 identifier. It is rated at 3.89 and it was originally published in 1960. Right? I want to find the worst book according to the ratings. I want to find the best book, the oldest book, and all books by a particular author. Okay? So now what we're not done with Java yet, but we are transitioning into Java and object-oriented programming. Remember back on day one, I gave you a theme of this course, that smart data structures and dumb code are a lot better than the other way around. When you start thinking in an object-oriented programming manner, you start thinking about not how to break this problem down and, okay, I need to open up this file and I need to process it line by line and I need to find the year. If I'm going to find the oldest book, I need to find the year and then I need to keep track of that and find the least value and then associate that with a book. You don't start with those questions. You start with, what objects do I need to represent my data? Right? And I've kind of outlined it right here. I want something to represent a book. Right? Well, what is a book? A book is a title. Right? A book is an author. Right? And what is an author? Author is a name, a first name and a last name. We also have a publish year, ISBN, and a rating here. And I'll go ahead and throw in an ID as well, right? A Goodreads ID, right? Because in some of my data, I do not have ISBNs. For example, Homer's The Odyssey, which I think is the actual oldest book in this collection. There's no ISBN, right? Because they didn't have ISBNs in 700 BCE, 3,000 years ago. So we definitely do have an ID here, okay? My question is, before I even start to break this problem down into smaller and smaller bits, I'm going to start at the bottom. What classes or what objects should I design in order to support this data? So I'm going to come over here and I'm going to create a book class, right? Class book. Now, why am I calling it book with a capital B? That's the convention. Is it books, the books class? Does that grammatically even sound correct? No. It's the book class. It represents books, right? But it is not books itself. It is one book. It is a blueprint for making books. Right? In Java, all classes are upper camel cased. So if I had book data or something like that, I would do that. Generally, you don't append data to it, though, right? In your assignment, we do have patient data, but that's not something that you follow generally. Right? A patient and a patient data are not the same thing. So a patient, you could create a class like that if you wanted to, but patient data is probably enough. All right, well, what defines a book? Let me bring these notes over here, right? And cut and paste as a blueprint, right? Well, what is an ID? An integer, okay, I like that. So let's make an ID. All member variables over here, right? If you did this in C, right? This is going to look very, very C-like. What you did is you created a structure instead of a class. And right for now, our class is going to be just like a structure in that it holds data. Okay? In fact, it's the same syntax. The type, the name of the member variable, and then followed by a semicolon. Right? What else is there? A title. So what's a title? a string, right? What about the, let's jump ahead here. And in fact, let's go in order of the data over here, so just so that we don't confuse ourselves. Here's the actual data in the file. There's ISBN. ISBN is actually a string, ISBN. Why didn't I go like this? Well, it's an acronym, right? So maybe you lowercase I and then SBN, right? Because that's the first letter of each acronym. Ugly, right? ISBN is a little bit better. Well, why not ISBN all caps there, right? In Java, if you have something that is all caps, that's telling me that it is a constant, right? And an ISBN is not a constant here. For example, you've seen this before with math.py. We have an uppercase PI. That's a constant. An ISBN is not a constant, so let's go ahead and call it what it is, ISBN. Sometimes you have to break the rules a little, or bend the rules a little bit, that not everything is going to be a lower camel casing convention, just because it's an acronym. I suppose if you really wanted to, you can go International Standard Book Number. Do you want to type that every single damn time? Nope. So let's go with ISBN. All right. The rating is probably a double because it is on the scale of 0 to 5, right? And you can have 3.5 as a rating. And publish year. I'm going to go ahead and go with year here as an integer. Right? But let's think about that for a second here and let's look forward. Right? When something is published, it's not just published in the entire year. It's published on a particular date. Right? So what if I had the entire data for that this was published on June 4th, 1960, right? Then what else would I want? Probably a month, probably a day, right? And at that point, I see three things right here. What is that screaming out to you if this were done in C, right? These three things formulate one thing. You'd probably want to do what? Create another structure representing a date. And that's exactly what I would do here, but I wouldn't reinvent the wheel. There's a local date built into the language, publish year, right? And I would actually use that. But we don't have all that date, so we'll come back to that later on as an idea. And for now, I'm just going to keep it as a year, okay? That brings me back to the author here. String last name, in fact, author last name, string author first name, okay? And now I've got all this stuff so I can go ahead and get rid of it, okay? That's a pretty good start. I'll ask you a question here about that though, but remember that all classes need documentation. Well, this is pretty self-evident. It represents a book. Represents a book, right? There you go. That's all you really need. Right? Each one of these things does not need documentation because it's just data. Good variable names tell you exactly what it is. If I did string A, and then I had to document that as, oh, this represents the title of the book. Oh, thank you very much for that stupid documentation. How could I have solved this a little bit better? By having an obvious variable name, title. Right. Here's another option. What if I had said book title? That's a little bit more descriptive, isn't it? Except that, what class am I in again? Book. Why am I repeating myself? Right? Don't do that. There's a DRY principle. Don't repeat yourself. Right? The DRY principle or the dry principle. Right? You want code to be as dry as possible. You're not writing poetry here. Right? You want it to be as self-explanatory as possible. But that's got me thinking about this because I've violated the DRY principle, right? I've got author first name, author last name. What should that be screaming out to you as well? It's two things that represent one entity. And by the way, we could go further. The author's birth date, which would be year, date, and month, or date. What else could we do? Their social security number, their what?
Another struct.
Another struct, or in this case, since we've got classes, a class called author, not authors, right? Or, you know what? Author. Okay, we could go with that. But what is an author? In computer science, there are only two difficult things: cache invalidation and naming things. What should I name this thing? I should name it what it represents. Maybe it doesn't just represent an author, because a person is an author, right? And a person could also be I don't know, a student, an instructor, whatever, right? What's even more general that I could maybe reuse this code in several different places? Person. I like that, right? Human, whatever, right? So string last name and string first name. There. Why didn't I put author in front of it? Because I no longer am in the context of an author. If this person is a student, I wouldn't put student last name. If they're an author, author last name. And now what I'll do over here in book is take those two things away and simply just give myself a author, which is a person. Once you've defined your own user types, now you can start modeling what your data actually represents. Those two strings represent a person. This collection of things represents a book. These multiple books represent a library, right? Now you can start talking about things as real-world objects, right? Before we go on, though, there's a much better way of doing this, right? So my first observation here is that if I create a book over here in the demo class, book B is equal to new book, that's one way of doing it. And then I could say title is equal to hello world, right? Or what was my first one? I'll do the one that I'm reading right now. Here we go. All right, let's do this. I've got to create a book for my current book, right? There we go. And I've created a new book just like I would create a new string or anything else using the new keyword here. And let's go ahead and start setting things. My current book is equal dot ID is equal to this ID. Right? My current book dot title is equal to the High Crusade. Right? The High Crusade. Typing. Right? If I want, eventually I'm going to get this done, right? But then I'm going to want to create another book, and another book, and another book, and another book. So this chunk of code here, where I end up setting all of those fields, all those variables, where does it belong? In a function, certainly, right? So that I can call a function to create a book. But does it belong here in the demo class? It's a book thing, right? And I'm in the demo class. Is it a math thing? Does it belong in the math class? It's not, doesn't do math stuff, does it? Right? So where does it belong? In the book class. Book things belong in the book class. Author things belong in the author class. That's called a constructor. Public book. It will take an integer, which is an ID, a string, which is a title. It'll take an author, or a person, excuse me, which is an author. P, there we go. And a string, which is an ISBN, a double, which is a rating, and a int, which is a year that it was published. And what I'll do is I'll set each one of those things. ID is equal to ID, title is equal to title, author is equal to that author, ISBN is equal to ISBN, and rating is equal to rating, and year is equal to year. Lots and lots of typing. I'll show you a better way here in a second. But before we do that, let's address what's going on here. The assignment to variable ID has no effect. What does that mean? Well, it's compiling just fine. It's just a warning, right? So let's move on with our lives. Don't leave warnings. Warnings mean things, right? It's trying to warn you that this code is dumb, right? Let me show you x is equal to 42. Would you ever write a line of code that looked like this on 19? I mean, it does something. What does it do? Here's my variable x. I'm taking the value out of it, and what am I doing? I'm putting it right back in, right? And what is the error message? The assignment to variable has no effect, right? Just like this has no effect, and this has no effect, right? The reason for that is that, let's just focus on the ID here for a second. There are two variables with the name ID. The parameter variable right here, but then also this field variable, this member variable up here. Which one is which? This one is referring to that one right there. This one is referring to that one right there. They're referring to the same variable. So how do I refer that I want this ID up here to be equal to that ID right there? I want to take the parameter variable that you gave me and put it over here into this object's ID. And for that, I use the this keyword. Let's come back out here to demo to understand this for a second. Right? And now, none of this is working, but don't worry about that yet. So if I create a book and I give it a name, my current book, right? The current book that I'm reading. That book has a name. Let's jump into that book class. Does this book have a name? I'm inside myself. I'm inside the book class now, right? I don't see any name here. Now, if you are a person, and you are a people, right? How do you refer to yourself? You don't refer to yourself in the third person. I don't say, oh, Chris did that, or Chris is teaching a course right now, right? Or Chris drove here in his Honda today, right? No. How do I refer to myself? Me, myself, I. Well, how does an object refer to itself if it doesn't know its name? This is a name that the demo class calls this particular book. The book class has no idea about that because that's in a completely different class. So how do I refer to myself? Me? No. Myself? No. I? No, because it's an object. Objects are not people. It's this. Right? So I'm setting this ID, right? This ID right here to that ID right there. Right? By the way, you can click on things. What I'm doing is I'm holding down the command button, and then things become clickable, and it takes you to the variable that it refers to. And it's taking me to that variable when I go this dot. It's taking me to that variable when I go just ID. I need to make the same change on everything else, so I'm going to cheat and use this dot with block selection mode. Right. Done. Okay. Why are you still complaining about ISBN? There we go. Misspelled it. Right. That was a lot of typing, wasn't it? Let me go ahead and get rid of that. Now you got to type it all over. Or maybe I shouldn't have typed it to begin with. Source, generate constructor using fields. Right? And I want a constructor with all of them. So you can select and deselect individual ones if you want to, and you can generate it there. I didn't have to type a single damn thing. Right? It took care of everything for me. Code generation. Is this the AI that I've heard about? No. This is just really old stuff, right? Right? What about person? Same things here. I'll leave that as an exercise though, right? Okay, let's come back over here. And now, when I want to create a new book, it's not letting me because I've got a different constructor now. This constructor takes the ID, the title, the author, the ISBN, the rating, the year, et cetera, and it takes all of those things. So let me go ahead and come over here to my data, copy that, bring it over here, and let's go ahead and change that to a string. I'm not going to be able to do anything with that author just yet. There we go. So all it's complaining about now is Paul Anderson. What I need to do is I need to create an author. A is equal to new author. Right? And then, whoops, A dot last name is equal to Anderson. There we go. A dot first name is equal to Paul. Right, there. And now it's fine. Right, I need to import, not author, what is it? Person with a capital P. There we go, person. Right. It's like a lawyer. There is a default constructor, a default no argument constructor. And it will be, if you can't afford one, one will be provided for you. So over here in the person class, if I don't define a constructor, a way to create something, it'll automatically give me that code to do it implicitly. But if the second that I define my own constructor, that constructor goes away. The second that you hire your own lawyer, then that free lawyer goes away. Right? Hopefully you never need a lawyer. Right? But never ever talk to the cops without one. Right? Period. Right? There's a great video, Shut the F Up Friday. right? From a couple of lawyers, never talk to cops, right? You'll never help yourself, even if you're innocent. So don't, right? Anyway, back to actual computer science here, right? Not lawyering stuff. Right? So here's my demo class, and I've created a book. Well, I don't want to just create one book now that I've created that stuff. Let's go ahead and create a lot of books. For example, I want to load up all of the books from that CSV file. So do you remember we wrote this code when we looked at file.io? There it is, where we processed it line by line, but we didn't actually do anything with it except for printing it out. Let's go ahead and load all these books up now. Right? This is just an example up here. I'm going to load up all the book data in this file right here. Right? And I'm going to read it line by line. And instead of just printing it out, what I'm going to do is I'm going to split it into each one of these tokens. Oops. Let's open it, I guess. I'm going to split it out into the first token, which is the ID, the second token, the third token, etc. Sometimes it helps to bring this over and put this into a comment just to remember the formatting and the ordering of stuff. That should not be there in your final submission, though. It's cruft. Get rid of it. So I'm going to go ahead and split it out into tokens. String tokens is equal to line dot, remember, split. And you can actually use regular expressions for that. Hopefully you pick up regular expressions at some point. I'm going to split it based on commas. Now, the tokens, the first token is the ID. So string ID is equal to tokens of 0. Right? That is actually an integer, isn't it? Yep, we made that into an integer. So how do I take that string, which represents an integer, and parse it out? Integer.parseInt, tokens sub 0. Right. There we go. And that's actually an integer, int. There we go. What's the second token? The title. So string title is equal to tokens sub 1. String author first name, last name is equal to tokens sub 2. And their first name is equal to the next token, 3. First name. Once I've got those two tokens, I can actually create an author now. Author A is equal to new author, right? And you know, it's kind of annoying that I'm going to have to set those. So let's go into that class at this point, which is a person, sorry, right? And let's go ahead and auto-generate all that code. Source. Generate constructor using fields, last name, first name. It is in that order because that's the order that I wrote them up here. And now down here, I can just go last name, first name. And not have to write both of those lines of code to set both of those. Good. Let's go ahead and get the ISBN, which is tokens of 4 I'm up to now. And then the rating, which is a double. We parse doubles using double.parseDouble, right? And that's going to be tokens of 5. Right? And finally, the year, int year, is equal to integer.parseInt tokens of 6. Right? There we go. And now I'm going to simply just create the book. Book B is equal to new book, passing an ID, title, A, probably want to call it author. A is a terrible variable name. ISBN, rating, and year. But you've got to spell everything correctly. Author. There. There we go. Now I've got my book. What do I do with it? If I want to open up that file and process the 100 books that I've got in this file, then what should I be doing with each one? Just forgetting about it? No? All right. What do you want to do with it? Add it to an array? Well, you need to know how big the array is to begin with, right? So I'd have to process the file once to see that there are 100 books in there, and then create my array that can hold 100 things, and then go through it a second time and process all the data yet again. Oh, say what? I could add to, can't add to an array, but I can add to something better than arrays. What was that something? A list, right? So let's create that list before we even start. a list of books is equal to new array list. Capital L. And now here I can add it, books.add B. Yay. Big chunk of code that does one thing. What does it do? It loads up books from a particular file. What if I wanted to load up books from that file, and that file, and that file, and that file? Should I cut and paste this entire piece of code? Function. Now, where does that function belong?
Class.
We could put it into the book class, but is it a book thing? It sounds more like a books thing to me. It loads up books. You could put it over here probably, but I like to separate. Eventually what will happen is you'll get into the God class problem. It's an anti-pattern, it's a bad habit to get into, where you've got one class that does so much. It sees everything, it knows everything, it is everything. Right? We don't want that. Right? We're not being paid, or we don't have to pay by the class. If you want another class, create it. Right? New class. I'll call it book utils, not Java. Right? And now you can, what's utils short for? Utilities, right? So utility functions. A collection of utility functions for books, or the book object. Let me show you something cool here. You can go ahead and link this and then a book. There we go. I think that this is how it works. Let me find out. Yep. There's my documentation, and it becomes a hyperlink. And it'll take me to the documentation for a book. Link, it should just be book, maybe? There we go. There. It took me to the documentation for a book. Represents a book, right? Stupid documentation, but this is pretty simple stuff. Public static list of book, load books. Where are you going to want to load books? From a file path. There. I've moved that code over, and instead of always loading from this particular file, we'll load from whatever file you tell us to load from. Before you continue, get rid of your cruft. Reformat everything. All looks good, and then we can return books. I did create it up here. Yep, there we go. That makes this code over here so much more compact, right? What I can do now is I can say my list of books is equal to bookutils.load books from that file, and get rid of all of that code. Right? Much better. Let's go ahead and get rid of this too while we're at it. It's just demonstration code. Well, let's print them out. For book B in the collection books, what I want to do is I want to make sure that it actually works. System.out.println that book. Okay. There's going to be a couple problems here. My first estimation is that it's actually going to fail with an exception. And it's going to fail on ID. Right? There is no, for input string ID. What's going on here? Right? Yet again, I want to show you the tool, right? That something is happening here, but I don't know what. So let me set a breakpoint and fire up my debugger, the little bug up there. Okay? Something is happening here. Okay? Well, it hasn't happened there yet. If I step over this, I know that the error occurs inside this function here. So I'm going to step into that function. Right? No problem with creating the books. We can move this over here. There we go. No problem with opening the file, right? And creating the scanner. No problem reading the first line. So let's examine the first line here, right? Nothing bad has happened yet. But if I look at the first line, does that look like a book to you? That looks like header data to me. So immediately I've found my first problem. Let's go ahead and stop. Right? And remember that in this file you've got a header format. Only lines 2, 3, 4, ... are actual book data. So how could I handle that over here? After I open it, of course, I need to waste that first line. I don't care about that first line. S dot next line. I'm not even going to put it into a variable. I'm just going to call the next line and throw it away. Right? That skips the first line. Okay, come back over here, see if it's fixed. It's fixed, and I saw a meme on Programming Humor that somebody was celebrating. I've made progress. I've got a different exception now, right? And so we do have a different exception now, right? Where is it happening? Do I know what line it's happening on? Yeah, right there. What line is it happening on in my function? Right there. So it's trying to parse an ID, and there's a number format exception. Well, which line in this file is it happening on? There are 100 lines here. Do you want to go into the debugger and hit next, 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 next 100 times for 100 lines before you get to the one that errors out? No. So I'm going to come over here and I'm going to set a special kind of breakpoint. In fact, ignore these. I already did it in another section. Let me go ahead and get rid of them all. I'm going to remove all the breakpoints. I want this program to pause when it hits this number format exception. Right? Not at a particular line, but on a particular event. When this bad thing happens, I want it to pause so I can take a look around. What gave me this error? Right? So I'm going to go ahead and add an exception-based breakpoint here. What kind of exception? Well, a null pointer exception. You could do that. But in this case, I want to debug for a number format exception. That one right there. Right there. Now, anytime that I hit a number format exception, it's going to pause execution and show me what's going on here. Right? Let's go back over here to the variables. Nope. Darn it. There we go. S. It's an empty line. Can I go up? Darn it. Can I go? I can't go up in the stack trace. Let's go over here to, where is it? Book utils. Is it going to let me look at that now? No, darn it. There is a way. I'm going to have to remind myself of how to do it, but you can look at different frames in the stack frames. Expressions, no. Breakpoints, no. All right. I'm going to have to remind myself how to do it. But in any case, it has stalled on this line right here, 102. Is there any book data there? Nope. So what's the problem? You're trying to process a book that doesn't exist. Let's think back to our C days. Right? So you've got a next line, you grab out your next line, and then you try to process each one of those tokens. Instead of relying on exceptions, let's be a little bit defensive about it. I should only be processing those tokens if and only if what? If there are 0, 1, 2, 3, 4, 5, 6 of them, I started out as 0. So how many tokens should I expect? If tokens.length is equal to 7, then I do all of this stuff. Right? If you're on an empty line, I can stop the execution here. If you're on an empty line and you try to split it based on commas, are you going to get 7 tokens out of that thing? Nope. So let's see if that works now. And I can go back to my Java perspective there. Right? It ran. No exceptions whatsoever. Right? But did it give me what I expected? UNO, ECE, book, and then this mysterious hexadecimal number. What's it doing? It's printing the memory address, the Java virtual machine memory address of each one of these things. I don't want that. I want a human readable version of this. So what you could do is you could go like b.title, right? And then concatenate that with, the year plus b.year. Before I continue though, the operation of converting a book to a string, that sounds like a book thing to me. If it's a book thing, where does it belong? In the book class. Right? And in fact, once again, I don't have to do too much work. I can go up here to source, generate the toString method. I don't want to print everything. I just want to print maybe the rating. Yeah, let's go ahead and print everything, I guess. Right there. It doesn't look pretty, but at least it generates something. So if I run this again, there we go. Oops, nope, I want, where am I? Come over here. I've got too many things open. Let's get rid of that. Let's get rid of that now that it works. Let's undo that. Collapse, collapse. There we go. So there's the book, the demo class. There we go. There. Oh, I guess it's not printing everything. Oh, duh. I did that. B. There we go. Doesn't look pretty, but that's what you get. Again, it's not smart enough to figure out exactly, well, what do you want it to look like, right? If you want it to get exactly how you want it to look like, then you're gonna have to do the code yourself. For example, I want it to be a title by, and then this dot author, right? And I will also concatenate, say, in parentheses here, the rating and space the year. There we go. And then concatenate an empty or an ending parenthesis there. This dot year, this dot rating, this. Strictly speaking, you don't need to use this in this case because there's only one variable in the scope that says title, but it's still best practice to do it. There. Now it looks a little bit different, right? Except for the author class. Right? What's it doing now? The same thing as before, printing out the memory address. So let me come over here to the person and generate a toString method here as well. Public string toString. I can just do this really quick. This return this dot last name, and then with a comma, and then this dot first name. Run it again, and there. Now that looks really nice. Let's see. The Black Cauldron by Alexander Lloyd, comma Lloyd, Lloyd Alexander, right? 1965. Okay. We've got some good data processing now. We can load up the data. We can print the data. Let's go back to our original thoughts here. We want to find the worst book. So here's my first attempt, right? Double lowest rating, right? And I'll go ahead and set that equal to 10.0 because everything is on the 0 to 5 scale. So if I start out up here in 10, the first book I find is guaranteed to be lower. If I ever find another book that's even lower, I update that. And so I need to keep track of the worst book. Initially, that'll be null, or yeah, null. Right? For book B in books, right? If B dot rating is less than the lowest rating so far, then I found an even worse book. So let's update the lowest rating to be B dot rating, and let's update the worst book to be B. When I'm done, I will have the worst book. This will work. Oh, sorry, worst book. There we go. So the worst book here is going to be, they'd rather be right by Clifton Mark Clifton. Let me put a separator here so that we can see it better. All right, just a bunch of, you can get fancy ASCII art if you want to. There we go. All right. And there's the worst book. They'd rather be right by Mark Clifton, 3.05. Right. All right, now find the best book. Copy, paste, change. Lowest becomes highest, worst becomes best. Is this a good pattern to follow? Probably not. Is there a better way? What if I were to sort them by rating? Then where's the word, say in descending order? Right. So highest rated books to the lowest rated books. Where's the best book now? Books.get what index value? 0. Right? So book, best book is equal to this. What about where's the worst book? The last one. How do I get the last one? Books, careful, dot size. There are 5 books. What are the indices? 0, 1, 2, 3, 4. So -1. Right? And you can print them out. Oh, by the way, don't forget your to-dos, right? I need to come back and actually do that. Right? System.out.println best is going to be plus B, or best book. And the worst is going to be, I like lining things up, so you can line up that, and then worst book right there. Well, are those the best books and the worst books? No, clearly not, because I've not done my to-do here yet. I need to sort them. So collections.sort. Right? We'll sort all the books. It's not going to work for the same reason that that we encountered last week when I tried to do something like this. Right? I'm Java. I'm dumb. Computers are told exactly what they are told to do. They do exactly what they're told to do. If you don't tell them how to do something, they don't know how to figure it out. Right? Obviously, if I just told them, I want you to sort these books in increasing order, in decreasing order according to the ratings, right? That's plain old English. That might work on like ChatGPT that has a large language model that is able to parse out that natural language and then do something for you, right? This is not. This is a programming language. You have to tell it, how would you end up doing this? Therefore, what we need is a comparator. A comparator tells the sorting algorithm, it goes like this. They're out of order, so you need to swap them, or they're equal. Leave them alone, swap them, because they're out of order. Let me cut and paste this. Bring it over here. But it's not going to be for strings. What is it going to be for? Books, ratings, but then I'm ordering the entire book by rating. CMP book by rating. There we go. And instead of strings, it takes a book A and a book B. Remember the basic pattern. It returns something negative if A comes before B, returns something positive if A comes after B, etc., etc. So how do I compare those two books? If A.rating is less than B.rating, I do one thing. Else if A.rating is greater than B.rating, then I do another. I return something. Otherwise, the only other possibility is that they're the same, and so you return 0. A's rating is, say, 2 versus 4. Are they in order if I'm going for descending order? Let me put that in the variable name too, descending. Or sometimes people just shorten it to desk. You're not paying by the character though, right? Descending. So is this descending right here? 2, 4, 6, 8, 10. That is going up. That is ascending. So in other words, they are out of order. Return something positive. Don't get fancy, just return 1. The only other possibility here is that they are in order, and therefore you return something negative. Once you've got that, now you can go ahead and sort them. Right? There. The best book, 4.48 by The Hate You Give by Angie Thomas. And then the worst book that we already found was They'd Rather Be Right, 3.05. Okay? All right. I want to do the other thing now. I want to find the oldest book. So how could I go about doing that? Book, oldest. Book is equal to question mark, question mark. By using searching and sorting techniques, how would you go about sorting the books now to find the oldest? The year? Okay. So I need yet another comparator. Copy, paste this stuff, and put it down here. I'm going to show you a better way. Okay? What I want is the comparator to do that for me. Let me grab this, though. Comparator, I'll call it, you want to go in ascending order or descending, it doesn't really matter. If it's an ascending, you generally don't put that because that's the default. So you don't go ascending. You just say that it's by year. There we go. I don't want to have to write that code. I want Java to do it for me. Comparator, you go ahead and build this for me. Comparing what? Right? the year of the book, right? No, that's not Java code, right? Once I've got that, I can go ahead and sort it though, using that comparator. We'll come back to it. And if it's an ascending order, where's the oldest book? Books.get 0. And I can print it out. Oldest is going to be the oldest book. Right. Now I need to come back and worry about this thing right here. Right. I want it to do the book year. Okay. Now, the way that I've written it right now, it's not going to be possible to do that. But what I can do is I can say, add a function to do it. Public int get year. Return this dot year. Once I've got this function, what I can say is, comparator, you build this comparator for me using that function. Book : get year. Right. This is really cool syntax because what it's saying is, comparator, I want you to compare a book using this function right here. So if it's got book A and book B, it gets the year of A, gets the year of B, and then compares them. And if this is less and this is less, then it returns positive, or if this is greater, it returns something negative. Returns something positive or 0 for you. I didn't have to write all this code for myself. All I needed to do was write this code. Let's run it. There we go. That's definitely the oldest book, Homer's Odyssey, at least in the collection that I've got right here. Right? And what did it do, by the way? Negative 700, so BCE, right? This would have been formatted better if we had used a proper local date class to do it, right? But otherwise I can get the newest one as well. Okay. All right, well, what else would you want to do? What if I want, I don't know, what if I wanted to list all the, so there are several books that were published last year. What if I want to print all books in chronological order, but if published in the same year, right, say 2023, I want to order them best to worst. Okay. Once again, let's build a comparator. What would you call this? By year, then by rating? Now we're, again, two difficult things in computer science, and one of them is naming things. That's getting really, really long, but at least it's descriptive, right? So I want you to compare it by year, and then comparing books by rating. Now I have to use a function here. I can't just say rating because that is a field member variable. This has to be a function. So let me go back and write get rating. Right? There we go. Then comparing. Now it's not going to work because that function doesn't exist yet. So let me come over here and start typing again. I don't like typing. Right? There's got to be a better way. Right? So is there a better way? Well, yeah, I've got that code that will auto-generate a constructor, will auto-generate a toString method, but will also generate getters and setters. I'm only interested in getters. Note here that it does not select year. Why? Because I already manually wrote it. But I can generate all that code. Get rating, get author, get ISBN, get getters, right? Without me having to type a single line. Oh, that's so much better. Look at that. Comparing, then comparing, right? Oh, and by the way, I don't want it that way. I want it reversed. Not reversed, right? What if you wanted it by, what is it? Oldest to newest, reversed. There we go. I could reverse that one and then do that one, but then reverse that. I could mix and match and do anything that I want. Right? I could do it by author next. Right? Let's see if this works. Let's print them all out with a separator there. Repeat the separator up here so that we can actually see it. There we go. There. So there is my new, there's the oldest, right? All the way to the newest, 2023. But if you look at the two 2023 books there, it's going to be best to worst. If you look at the 2022 books, of which I have several of them, right? Best to worst. Oh yeah. Yeah, I would agree with that. Cormac McCarthy is dead, and they published this posthumously, and I think it's just because they found it in his collection, and you know, authors don't get to dictate what happens after they die. So he probably never, he wrote it in the 60s, I think, or something like that, and he never intended for it to be published, but his estate went ahead and published it, and why? It wasn't very good, right? So I've got 2022, 2022, 2022, but within all of those, I've got best to worst. Is that what I originally wrote, by the way? Best to worst, yes, I did. Same year, in chronological order, I achieved that. But I didn't have to write much code to do it. I let the comparator class take care of all that for me. All right. Cool? All right. Let's go ahead and do yet another one. One more here, because I want to show you one last thing for today. Print all the books, not in chronological order, but in authors by author. That is last name, first name. Why do I specify both last name and first name? Well, let's take the Dune series by Frank Herbert, and then it was taken over by his son Brian Herbert, right? Who should come first? Well, alphabetically, Brian comes first, even though he's not as good of an author as his father, but there we go, right? It's going to be last name, first name. But for everything that has the same author, what I want to do is I want to list them, say, in chronological order, right? Then by publish year, right? So how would I go about doing that? CMP book by author, then year, right? Okay. So instead of getting the year, get author, and then instead of get rating, get year, right? And then print them out again. It doesn't compile anymore. When I did this, this was an integer. Java knows how to order integers. When I did this, it's a double. Java knows how to order doubles. It knows how to order strings. But this is something completely new. What does get author return? Careful. Is an author just a string? No, it's a person. So if you want to, what you can do is you can build, so the question is, how does Java know that integers go like this, 5, 10, 20, 30, 40? Well, somebody wrote the code to do that. It wasn't just a simple matter of, oh, it magically knew how to do something. Integer foo. Let's look inside the class to see how it was done. It's not a comparator. Instead, it says that it's comparable, right? And it's not compare, it is called compare to. There we go. Right. Here's another value. I'm going to compare this integer's value to that integer's value, right? And then this compare function probably just, yeah, it's a ternary check, right? If x is less than 0, less than y, what do we return? -1. Otherwise, if they're equal, what do we return? 0. Otherwise, we return 1. Right? Little compact, clever code. We can do the same thing with our classes. Implement comparable, and what are you making it comparable to? Person. Apples to apples, oranges to oranges, people to people. It would be wrong if I did something like this. A person is now comparable to a book. You don't want to compare apples to oranges. You don't want to compare a person to a book. A person is not a book, and a book is not a person. A book is a book, a person is a person. Now it will let me generate this compare to method. Right? I'm going to call it that. That person and this person. I want to compare them. Right? Here is where I put the logic. Right? If this dot last name dot equals, or actually let's do it this way. Int result is equal to this dot last name dot compare to that dot last name. Right? Now, if I compare the last names, one of three things is going to happen. It's going to be something negative. In other words, this person comes before that person, right? Anderson comes before Zenith, right? Or it's going to be out of order, in which case Zenith should come after Anderson, and so I want you to swap them. Or it's going to return something negative. In other words, Herbert and Herbert. 0, right? If the result is 0, we have a tie. Right? Tie. Herbert and Herbert. What should I do now to break that tie? Go to where? Well, there's no rating in the person class, though. Right? There's just last name, and let's get rid of foo. I go to the first name. So I say result is equal to this dot first name compare to that dot first name. Now what happens when I've got result? What happens when I've got Herbert Frank and Herbert Frank? Those are the same authors, right? There's no other way to break ties here. You only have a last name and a first name, right? So if you had something, say, like a social security number, then you could go ahead and break ties that way. Because there are bound to be 2 Frank Herberts in the world because we've got billions of people. But no 2 of them are going to share that same social security number. That's called a natural key, or sometimes it's called we use surrogate keys instead. We'll cover that when we get to databases. Now let's come over here. Everything compiles now over here in the demo class once I kick it in its butt. Remember what I wanted? I wanted by author, which is now comparable, so that author and that author, you can compare them. But I want it reversed. Oh, do I want it reversed? No. Let's go in alphabetical order. Then comparing the year, but reversed so that it's the newest to oldest, right? Newest to oldest. There we go. Run that, and let's take a look. Right? So there's the beginning. No, that's not the beginning, is it? Oh, why does Homer get to be first? Does Homer have a first name? Or does Homer have a last name? I don't, Homer. I don't know. Anyway, there we go, Wells, and Wells. And they're all together. And are they in chronological order? Looks like it to me, right? So it looks like I went last name, first name, author. Let's go back to the person class. This dot last name compared to that last name. Why is it not going A to B or A to Z? That's whatever. I can go ahead and reverse it. I'll have to figure that out later. There we go. There, now right is down here. Brown is down here. There's still something funky here. Am I doing something wrong? Oh, I know what I'm doing wrong. If you're going to have a comparator, what should you do with it? Actually do something with it. Collections dot sort books with respect to that comparator. Now I don't reverse. Right. So let's put a couple of these things in here so that I know what I'm looking at the correct one. There we go. There. Z, W, 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 and then V, V, V. But for Jeff Vandermeer there, I've got all 2014. It's a trilogy, so I can't believe you did that all in 1 year, but whatever. Then Thomas, T, all the way down here at the end. We've got Adams, Alexander, and where are all my Pratchett books? Pratchett. There we go. Terry Pratchett. Uh-oh. Why is David Sedaris right in the middle? Oh, this is a mystery. Weird. What's going on? I'm in the correct. Oh, I don't think I'm in the correct one. There we go. I should be looking for Pratchett. Here we go. Here it is. There's all the Pratchett. Well, 5 Pratchett books there. Right. And they're in they're in chronological order, but reversed. The newest first, and then the oldest. Right. And again, that was posthumous, and so that's why it's the worst. There's a bunch of stories that he wrote when he was just a kid, so can't expect them to be great. Right. All right, questions on that? No? Then I'm almost to my last demonstration here. All books by Terry Pratchett. Well, we could do that and then, go through and say, okay, well, that's not by Terry Pratchett, don't print it. That's not by Terry Pratchett, don't print it. That's not. And then when I finally get to Terry Pratchett, they're all contiguous. They're all right there. Right? Now print. But should I be looking at everything just to get all to that point and then print stuff? No. What kind of searching techniques do we have? Use binary search. Right? Since it's already sorted with respect to author, I can find it by author. Right? So step 1 is let's just sort by author, which we already have. 2, binary search by author. Right, ... We'll pick it up there on Thursday. We're going to have to create a key that represents Terry Pratchett. That's easy enough. Person, Terry is equal to new person, Pratchett, Terry. There you go. There's my key. Now how do I go searching in my haystack for a book by Terry Pratchett? Right? Then we'll look at an even better way of doing it. Better data processing using smart data structures. Right? Smart data structures, we've already covered them before. Lists, sets, and what am I thinking of? That other one that rules them all, maps. I'm going to map an author to a list or a set of books they've written. That's the ultimate right there, because I'm not just answering it for Terry Pratchett, I'm answering the question for all authors. Right? And that's going to be a way better solution. All right? We'll show that on Thursday. I'll see you.